Now we come towards the coefficient of static friction. Now normally rule is that coefficient of friction is represented by mu. It is defined as the ratio of force of friction to the normal reaction. Normal reaction is always mg. Force of friction is ma. If m will cancel off, we will find that the coefficient of friction is independent of mass. Because if we write mu is equal to F over S, F can be replaced by ma and weight, normal reaction can be replaced by mg. So the function will become mu is equal to A over g, or A is equal to mu times of acceleration due to gravity. Now we can put this concept in the form of static friction or the coefficient of static friction. Moreover, you can understand that coefficient of static friction or simply friction, that is mu, has no units because it is the ratio of force of friction to the normal reaction. Normal reaction is also force and force of friction is also force. So in the numerator and denominator, the units will cancel off and mu will become a dimensionless constant. Now we will put it in the context. The limiting friction FL is proportional to the normal reaction N. Therefore, FL, that is the force of limiting friction, is equal to mu S multiplied by N, where N is the normal reaction and mu S is the coefficient of static friction. Now, mu S is equal to force of limiting friction to the normal reaction. This I have just explained you that coefficient of friction is the ratio of the force of friction to the normal reaction. Now, because FL and N both are the forces, so if we put their units, we will find the units will cancel off and mu S will have no units. It will be a dimensionless constant. So if you wanted to write its dimension, it will be m naught, L naught, T naught. Otherwise, we say it is a dimensionless constant. Now we come towards the dynamic friction. Now, on the surface, suppose that a block is moving. Now the friction arising between the two surfaces will be known as the dynamic friction and it will be represented by Fk. Now we can put it in this context. In the A part, that is, if applied force is increased further and sets the body in motion, the friction opposing the relative motion is called the dynamic or the kinetic friction. Kinetic friction is always lesser than the limiting friction because limiting friction means overcoming the friction and the body just slide. So limiting friction is always greater and kinetic friction is always less. So we can put the context like this, that kinetic friction is lesser than the limiting friction. Now we can write the relation of the kinetic friction as we have written the relation for static friction. The force of kinetic friction is equal to mu k multiplied by n, where n is the normal reaction and mu k is called the coefficient of kinetic friction. And otherwise we can say that mu k can be written as Fk over n. Again the units will cancel off and mu k will have no units, it will become dimensionless. Now Fl means force of limiting friction, Fk means force of kinetic friction, mu S means the coefficient of sliding friction, mu k means the coefficient of kinetic friction. So what exactly we see? That force of limiting friction is greater than force of kinetic friction and is equivalent to mu S greater than mu k. That is, we require more force to start the motion in a body than to maintain it against the friction. Now, we further find the friction force which is effective on sliding of the two surfaces. If both the surfaces slide, whatever surface is in contact, if both are sliding, then we will say that friction among the surfaces will be the sliding friction. So sliding friction is basically when the sliding surface as well as the body on it both are sliding, moving. Now when we speak the rolling friction, it is represented by mu r. We take an inclined plane and it is inclined at angle theta. Then if a ball is placed on the plane at a certain angle, then it means that just a point is in contact with the plane. So we find that there will be friction, it is very, very less, and the body will move faster. So rolling friction means friction between the surfaces in which one of the body is rolling over that surface. So we can put it in this context: when a body rolls on a surface, say wheel or a ball is rolling on a surface, the resistance offered by surface is called rolling friction, and it will be very small because in contact there will be a point of the body. Now we come towards another point, that is the rolling. In the rolling, the surface at contact do not rub each other because it is a point contact. Now we come towards the angle of friction. So angle of friction means that a body is sliding down, the plane is inclined at a certain angle, and there will be friction between the two surfaces. So that will be the angle of friction. Now we can see here, that is on the figure, there is a block. The right arrow is indicating the block has to slide towards F, and downward force is weight, that is mg, and normal reaction is N. So N balances mg. R is the normal reaction inclined at a certain angle to the normal line, and that angle is lambda. So the normal reaction in this case will be the force of limiting friction plus the normal reaction. FL is indicating the direction of the limiting friction. So applied force is F and the limiting friction is opposite to F. So FL is opposite to F. Now we can put the whole thing in this context like this. The angle of friction is the angle which the resultant of the limiting friction FL and the normal reaction N makes with the normal reaction. It is represented by lambda. Thus, from the figure, tangent lambda. Now, tangent means perpendicular over base. So, if we consider R and N, and if we draw perpendicular from R to N, it will become a right angle triangle in which the side opposite to angle will be perpendicular. So, the direction of N will become a base and R will be the hypotenuse. So, we are finding here, that is FL over N will be tangent lambda. That is perpendicular over base will be tangent lambda, because FL is equal to mu N. So we can say mu N will be, or tan lambda is equal to mu N over N. N will cancel off, and the angle of friction, tangent of the angle of friction, will be equal to mu, where mu is called the coefficient of friction. If the surface is smooth, polished, and friction is very, very less, then for a smooth surface, lambda will be 0. Now we come towards the angle of repose, and for that we consider an inclined plane as shown in the figure. A block is kept on the inclination angle theta of the inclined plane. So inclined plane is indicated and the plane or the surface is inclined at an angle theta. A block is placed over the inclined plane. Now according to the diagram, weight mg is acting vertically down, and the normal reaction will be at 90 degrees to surface acting vertically up. Now mg can be resolved into two rectangular components, the horizontal component and the vertical component. So between mg and mg cos theta, the angle will be theta as that of the angle of inclination of the plane. Now n is balanced by mg cos theta, and mg sin theta and FL are in opposite direction. The force of limiting friction is in the direction FL, and mg sin theta is opposite to it. Now we can put it like this: the angle of repose is theta, that is the angle of inclination of the plane. If a body is placed on an inclined plane, And if its angle of inclination is gradually increased, then at a certain instant we'll find the body begins to slide down. So once more I will repeat that in the inclined plane, a block is kept. The movement will start slightly increasing the angle. Then at a certain instant, the block will start moving down. This can be put like this. If a body is placed on an inclined plane, and if its angle of inclination is gradually increased, then at some angle of inclination, the body will begin to just slide down. This angle is called the angle of repose, at which body is just sliding down. Now we will write FL balanced by mg sine theta. So FL is equal to mg sine theta, and normal reaction balanced by mg cos theta, that is n is equal to mg cos theta. Now we find that FL and N are at right angles to each other. We will use the definition of the angle of friction. So tangent theta is equal to FL over N, but mu is equal to tan theta. So we will say mu is equal to FL over N. Numerically, the angle of repose is equal to the angle of friction. So this is, I have already explained the diagram, and this whole statement is in accordance with the diagram.